Hey everyone, this is Prof. E or Prof. El Melody. In this lecture, we are going to go over the syllabus and also we're going to go over Chapter 1 PowerPoint slides. So it's very important. This is the most important information. D2L is the best way to contact me. I mean, you can email me through Outlook, but the best way, easy way, is through D2L. And this is my email. Okay. Now the program I'm going to be using, or the IDE, the programming platform, is Visual Studio. Now here I posted a video that shows you step by step how to install Visual Studio using the community version. So if you click on this link, it should take you to the video. Please make sure you take time to watch the video and follow it step by step. Okay, and then also it shows you how to create your first project in C++ using Visual Studio. So let's go over the syllabus very quick. So this is the syllabus for fall 2024. Of course, it starts with the basic information like the office hours. It's every Wednesday from 10 to 11 a.m. or by appointment. Of course, you feel free to ask any question during class, either before or after. And course information, all the information here. So please take time to go over it. This is the material or the textbook we're going to be using. So starting out with C++ from Control Structures to Object Oriented, edition 10 by Gaddis. Okay, so this is the learning outcomes. So basically in this class we are going to cover the basics of programming. So this is Programming Fundamentals 1. So this is all these are information about the tests, quizzes, discussion. We're gonna go over it in a minute. So this is the breakdown. So we have quizzes is 20%. Programming assignments. Every chapter there is a programming assignment and counts for 20%. And then also we have two projects, project 1 and project 2. And then we have midterms and final exam, that's 30% together. And then we have some participation grade and discussion. So some of them are short video, very short video that you need to watch, and then you answer probably 5 questions, no more than that. Or there is a discussion, anything under this participation and discussion. All right, so this is the schedule. So as you can see, it shows week by week what are the materials to be covered and the assignments. And by the way, to make it easy for you, in D2L on top of the page it shows you which assignments are due for that week. So let me show you an example here. If you go to content, for example, and then you go to the week number 1. So if you know which assignments are due, then just look on top right here. So we have 3 things. Introduce yourself, which is right here. So you click on it and then basically just introduce yourself, and then you reply to 2 students. And then we have video quiz 1. There's a video here. Once you watch it, see, you click on it, it says what is computer science all about. So once you watch, you cannot answer the questions without watching. You have to watch the video first. It just talks about computer science as a field and then the different options students have. So watch the video and then answer some few questions, video quiz 1. So that's part of participation. So it's not a quiz like 20%, it's just 10% as a participation. And then we have the chapter quiz 1. So we have 3 things are due by September the 2nd at 11:30 p.m. Okay, the same thing. If you go to week 2, you're gonna find the same thing. So in week number 2, you have also 3 things: program assignment 1 and 2, video quiz 2, watch like a little short video and then you answer the question, and the chapter quiz 2 about what we covered during that chapter. And the same thing for the rest. Okay. All right, so let's get started with chapter 1. So we're gonna go to week number 1, and then we are going to click on the PowerPoint slides. So the first chapter basically is just a general overview about computer and programming. So first of all, what is program? Why we should program? So there are some terms, some words that you need to be familiar with, because we're going to be using them frequently. A computer, of course, is a machine. It's a programmable machine designed to follow instructions. The computer does exactly what the programmer asks him to do. Okay? And by the way, a while ago, computer used to refer to a person, not a machine, like a plumber, like carpenter. So computer used to refer to a person, not a machine. But after, after a period of time, it started referring to the machine itself. Now, what is a program? Program is a set of instructions that are stored in the computer memory to make it do something. So we have the smallest thing is instruction. A set of instructions make a program, and set of programs makes a software. So this is like the relationship between them. And of course, the programmer is the person who writes instructions, who tells the computer what to do. So without programs, of course, there are no programs. The computer system is divided into 2 parts, hardware and software. I'm sure you heard these terms many times, so it's very important that you make the distinction between the two. So a hardware basically is the physical aspect of the computer, anything that you can touch, that tangible, anything that you can feel and touch. Software are the hidden part, like the program itself that you cannot touch or see. Okay. So what are the components of the hardware? There is a CPU, or central processing unit. That's basically the brain of the computer. And then we're going to be talking about the different parts of CPU. But if you want to know in detail about CPU, there is a specific class called Computer Organization and Architecture that talks in detail about what's happening and what happened inside the CPU, which is outside the scope of this class. So we're just going to kind of give like a little description of the CPU without going into details. And then also one of the most important components is the memory. Okay, so we have 2 types of memory. We have the temporary memory, so when you are typing, for example, a letter or document, as long as there is a power, it is saved. But once the power goes out, then all the information is gone. So this is called the main memory. And there is a secondary, or you can call it long-term memory. That's for long-term storage. So sometimes we use the hard disk inside the computer, like you want to save under My Documents or desktop, or you can save in a flash drive. That's also long-term. So there are different ways you can save. This is called secondary long-term memory and storage. Input device and output devices are basically the devices that connect to the computer, either for input purposes or output, because sometimes we need a device to get the information inside the computer, like the keyboard, for example. What do we use the keyboard for? So we can get the information inside the computer. The same thing for scanner. The same thing for a mouse. All of these devices are input. Now, output is the opposite when you try to get the information out. Like for example, the monitor. What do we use the monitor for? To get the information out. The same thing for the printer. The same thing for a speaker to get the voice out. So the either input or output. So this is an example. Of course, some of them are no more used, but these are examples of inputs and outputs. Now let's go back to the CPU, which is the brain of the computer. So it is made of two parts. There is the control unit, and there is arithmetic and logic units. The control units are basically, you can call it the police officer who makes sure that everything is organized, who's going to go first, which instruction is going to go first, which one is going to go second. So everything about the organization is controlled or is managed by the control unit. Okay? Now the arithmetic and logic unit is responsible for the execution, for the computation. Anything that is arithmetic, calculations, computation is done in this section, which is arithmetic and logic units. So this is like a very simplistic, maybe of course like it's more complicated than that, but this is a starting point. This is a very simplistic definition or description of the CPU. Okay, so there is the instruction, and then that instructions needs to be processed by the arithmetic and logic units and managed by the control units, and then after the processing it will come out as output. The main memory, we talked about the main memory. We said it's volatile. Volatile, that means it's not a long term. If anything happens, you lose all the information, okay? RAM, random access memory. So again, so this is only for temporary storage. If you want to store something for long term, you need to put it in a secondary or long term storage. Now, memory is basically like a space inside the computer. If you cannot save something in the computer, it's gone. The computer cannot retrieve it. Okay? And then it is based on bits and bytes. So this is basically how we measure the memory space. That's why we talk about kilobytes, megabytes, terabytes, and so on, gigabytes, and so on. Okay, and then just like in houses, like in real life, every house has an address, right? So it will be easy to locate that house, okay? The same thing for the memory. If the information is not saved in a specific address, then it's impossible for the computer to retrieve that when you want it, okay? It has to have address. So this is an example, okay? Every address is specified, and every information is stored in a specific address. Now, secondary storage, we said it's for long term. Okay, so there are different ways you can save the information. It used to be magnetic, so most of them here they are not used anymore. CD-ROM, it's not used, or DVD is not. So every time they come up with something new, with the new way of storing the information. Flash drive, they're still being used, but not as often as they used to. Why? Because we have different ways, maybe more sophisticated ways to save the information. Like many people, they save now in Google Drive, or they save in a specific place because it's more convenient. We talked about input devices. So we said that input devices is any input that you can use to get the information inside the computer. Like keyboard, mouse, touch screen, scanner, all of this, we use the microphone, we use them to get the information inside. Now, what's the difference between software and program? We talked about this. We said instructions, a set of instructions made a program. Like when we start coding, we're gonna have statements, one after the other. So when you put them together, it makes a program. And then when you have programs, like 2, 3, 4, 5 programs, that makes a software. Okay? So we have two types of software. We have a system software, and then we have the application software. So system software is basically the program that manages the computer hardware, like Windows, for example. So why do we need Windows? Windows is basically the intermediary between the human being and the machine, because machine, they speak a different language than human beings, so you need something in between. So Windows, as an example, plays that role to for common. It's like when two people, they speak two different languages, they need someone in the middle to translate. So that's pretty much the same thing. Now, what about application software? Application software is a software that we use, or a program that we use for a specific task. Let's give an example. Microsoft Word is an application software. Why? Because we use it for a specific task, which is a word processing, to type a document. Now, if I want to make a presentation, I'm not going to use Microsoft Word. I'm going to use something else, which is more sophisticated, like PowerPoint. If I want to keep track of my database, there is a software for that. For example, Microsoft Access. I'm just giving an example because most of the time we use this application softwares. So we use it only for that specific task. And the same thing for Microsoft Excel, for tables, for calculations, for analysis. Yes. All right. Now let's talk about the different levels of programming languages. So we said that the program is a set of instructions that the computer follows step by step in order to perform a task. Now we have different levels. And by the way, the algorithm is a step-by-step instructions. So when we say algorithm, we mean step-by-step, very specific step-by-step instructions. So just to give an example, if a friend of mine, for example, came from California or from New York, and then he wants to go to the airport here in Houston, you need to give him very specific instructions. So we call it algorithm. Okay, so I will tell him, okay, you take, for example, a specific street for 2-3 miles. Once you get to I-10, okay, then you make a right, and then you take the I-10 until, let's say, 10 miles, and then take the exit for 45, for example, and then take 45 north toward Dallas, and then go a certain number of miles until you exit, and so on. All of these are step by step. And that's what Google Maps does. It gives you step by step instructions. So we call it algorithm. So this is an example, like algorithm to calculate the gross pay. So there is step number 1, number 2, number 3. Of course, we're going to get to this in detail once we start the programming part. So machine language, we mentioned that. We said that the machine language is the lowest level of language when it comes to programming, because that level is basically made of 0 and 1, because that's the only language the computer understands. Okay, so we call it machine language. And then of course we have a little bit higher level. It's called assembly language, which is in between. Okay, we have some English words, very limited, and the rest is basically symbols and numbers. And then there is the higher level, which is close to the human being. That's the higher level. We call it higher level programming language. Okay, so when you type a program, when a programmer types a program, it goes through different steps to make sure that that program is translated and interpreted, in such a way that it becomes understandable by the computer, that the computer can understand. Alright, so this is an example of a machine statement, language statements. So as you can see, just a bunch of zeros and one. That means something, of course. So we have low level. So low level, closer. When you go lower, you become closer to the machine language. When you go higher, you get closer to the human language. So this is examples of the most popular programming languages like C++, Java, Python, and so on. So from a high level, as I mentioned, from a high level program to an executable file, you go through these steps. So you create a file containing the program with the text editor. So you have to type the program. So we use a variety of programs for that purpose. We can use, for example, Visual Studio. We can use Eclipse, depending which programming language we are using. There are a variety of them. And then run preprocessor. Preprocessor are files that help us in our programming. It makes our programming experience much easier. Okay? And then you run the compiler to convert. See, you convert the source program into machine instructions. So you need a compiler for that. And also you're going to run something called the linker that will connect the hardware specific code to the machine instructions. Of course, as I mentioned, so there is a class specific for this if you want to go into detail. So for this class, we don't have to go deeper. We just go in, basically, we're just scratching the surface. Okay? So this is an example, or it shows the steps that the programs go through from the source code until it becomes executable code. Okay? IDE, so we said IDE is just like a fancy word for programming platform. If you want to program to code, you need a space for it. You need a program where you can type the code, and then that code or program needs to be converted and translated into machine language. So the program, we call it IDE, Integrated Development Environment. Like, for example, Visual Studio, Eclipse, JCreator. So we have a variety of IDE that we use, depending which software, or I'm sorry, which programming language we are. Like for C++, we use Code Warrior. The most popular, of course, is Microsoft Visual Studio, but there are other types also. There are other programs. So what is a program made of? So if you look at the program, and we're going to starting from chapter 2, it's made of the following. You have some keywords that have special meaning. Okay, like C++ will give us some keyword that they have a special meaning. They're not like a normal words. They mean something for the computer. That's why usually you're gonna find them in a separate color, so you can easily identify them. And there are programmer-defined identifier. These are the variables that we create, the programmer creates for that program. Operators, like the symbol that we use to compare two things, to add, subtract, all this calculation. And then of course we have punctuation that we're going to be using, like the semicolon, for example, the parentheses, the double quote, and stuff like that. And then the syntax. So of course the best one, this is an example of a short, very simple program that calculates the weekly pay or the gross pay of an employee. So of course we're going to get to this into detail. Keyword, we said keyword is a word that has a special meaning for that particular programming language. Sometimes we call them reserved words. So they are, you cannot use them, you cannot create a variable using this keyword. Why? Because that's going to create confusion for the computer, because it means something for the computer and you are using it for something else. Okay, so we're going to get to that. So when we create our first program, we will get into that. Programmer defined identifiers. I said these are names, and these names, they have to have rules. You cannot name it anything you want. Well, you can. You can name your variables anything you want, as long as there are certain rules are respected. Okay, for example, you have to start your variable with alphabetic or underscore. You cannot start with the number. So if you name your variable starting with the number 5, 6 or something, so that's going to be invalid. That's going to create an error. This is just one of the rules that C++ have for naming identifier or variable. Also, you cannot leave a space. For example, if your variable is called grade average, you cannot have a space between grade and average. You have to connect them, or at least put underscore in between. Also, you cannot use a keyword for your variable. So there are certain rules that we have to respect. Operators, we're going to talk. So this is something very similar that you learned in math. There is no difference. We follow the PEMDAS, or the order of operation, just like in math. So other than that, everything is the same. So the punctuation, the most frequently one is comma, because we separate variable using comma. And then we end every statement by semicolon. Semicolon is like the end of the statement. And then we use double quotes for text, and then we use some symbols for other purpose. We're going to get to that. Okay? So variable, what is a variable? So variable, I'm sure you heard about this or used it in math. It's almost the same thing, but in computer science there is something extra. So variable is, as the name implies, something that changes, that varies. Why? Because it takes different values. Sometimes x is 5, sometimes it's 2. Okay, so if it changes, we call it variable. But in computer science, it's more than that. It is a specific place. So when you create in the memory of the computer, so when you create a variable, basically you are assigning a spot in the memory of the computer, so the computer will be able to retrieve it when you need it. Okay, and that variable depends on which type. If it's a number, is it integer, is it double or decimal, is this a character, is it text? So there are different types. We're going to get to that in chapter 2. So we use variable to keep track of our information, because if we don't save them, then they're going to be lost. So that's an example. Hours is the name of a variable, so we can keep track of how many hours the employee works. The rate also is another variable, but it's going to be decimal. We call it double, because the rate usually comes with point something, like, the employee gets 35.75 dollar, like per hour, for example. And the pay, you multiply the two, so most likely it's going to be decimal as well. So this is, as we mentioned, the variable definition. To create a variable in a program, you must write a variable definition. We call it defining or declaring a variable. How do we declare them? By mentioning what data type. And the best way to learn this, I don't want you to freak out about this, because the best way is to have the program, is to practice it. And that's what we're going to be doing starting from chapter 2. So I'm just giving you an overview, but we're going to get into detail. The best way to learn all of this is by practicing, by creating our own program. So this is an example of declaration. So here what we are doing, we are declaring 3 variables. All of them, they have the same data type, which is double. Double is another way to say decimal. So we have hours, we have the rate, and we have the pay. Now we can declare them separately, but that's going to be, you have to repeat double 3 times. But if they share the same data type, we can combine them into one statement. Okay. So input, processing, and output. So this is 3 steps that every program has to go through. When you write a program, you have to go through 3 steps. First one, you have to gather all the information. For example, let's go back to the example of gross pay. So before I can calculate the gross pay of an employee, I have to get the information about how many hours the employee works, how much he gets paid per hour, and then any information I need. His name, for example, or her name, any information I need. And then you're gonna process. Process means make any calculation that you need to make. For example, if I want to know what is the weekly pay, I have to multiply the hours by the pay rate, okay? And then finally, once you have all this information ready, then you display them. That's the 3rd step. Okay? So as I mentioned, we're going to go into details about each one of them. All right. So this is chapter 1. If you have any questions, please let me know. Thank you so much for watching.